Oh, nice. Lots of highlighting there. I love it. Okay. Oh, this thing's being silly right now. Why is this thing not at the bottom? Hey, I thought we fixed that. Oh, I know why. It's because I ended up logging out of the computer at some point. And I didn't like it. What was it? It was edit. But view. Customize. Huh? Layout. Dock right. Let's say dock bottom. Hey. Now we got it down. Now I know. Genius. Okay. Folks, the other day's homework was so important because it allowed us, well, not only to remember, but also like reinforce the idea that we can solve for the equation of any line in a number of scenarios. Whether we're given a scenario where we have the slope and a point, where you get the equation of the line, or really the tougher one out of the two scenarios would be having two coordinates. You have two coordinates, get the equation of the line, and if you've done the other day's homework, should be in great shape. I want to talk about some new terminology here. First of all, a bisector. A bisector is this red line, this red vertical line here, that's going through the line segment AB. Okay? So a bisector cuts the line segment AB. Notice how it's into two equal parts, right? A line that divides a line segment. Now, let me make this thing a little bit. Yeah. Two equal parts. Absolutely. Now, if that's the case for a bisector, then if we look at coordinate AB, what point on on line segment AB does the bisector go through? What point do you think it's going through here? Yeah, it has to be, right? The midpoint. So this coordinate right here that the bisector will go through must be the midpoint. Oh, it's not working. Midpoint of AB. Has to be. That is for sure. Now the bisector can go through the line segment, any which way it kind of wants to, as long as a line goes through the midpoint of a line segment. We call that a bisector. And think about it, the prefix bi, almost like a binomial or a bicycle, we're talking about two. So what we get out of this is just two equal parts. Yeah? So far, so good? Great. Now, the reason why we needed to learn about a bisector is because what we're going to be dealing with today is a very specific type of bisector, and we call that a perpendicular bisector. Think about the word bisector. We know that the line segment is going to go directly through the midpoint, for sure. It's going to bisect a line segment, but not in any which way possible. It's very specific because this is a perpendicular bisector, and a perpendicular bisector goes through a line segment, but at a perpendicular angle. Yeah? So it says here the line that is perpendicular to a line segment, so perpendicular to a line segment, love it, and also divides it into two equal parts. So again, this coordinate right here, it must be the midpoint of AB. The midpoint of AB has to be, because it's got the word bisector in there. Now, the fun part of this comes right here. When we talk about right angles, remember when we were classifying and verifying shapes? When we were talking about right angles, what did we know about the slopes of right angles? Yeah. So like we have line segment AB. It's got some slope. What has to be the slope of the perpendicular bisector? What's the relationship going on? That's right. There's going to be some sort of negative reciprocal occurring here. And that's an important thing to note because whenever there is a right angle, this perpendicular, whenever you hear that word, we've kind of got to be thinking, negative reciprocal. That's what's happening. So far, so good? Okay. The last thing here we have is a median of a triangle. The perpendicular bisector occurs on a line segment, but the median occurs on a triangle. It's a line that goes from one vertex, doesn't matter really which one, just one vertex. Oh, but I was on highlighter. From one vertex to the midpoint of the opposite side. So for this, in this particular example, we have the median from vertex C to AB. So that's what we would say, from C to AB. And of course, because it's a median, it's got to go through the midpoint of that side. Yeah? Questions about that? Some new terminology, maybe? Okay. I kind of want to just add in something here. Now, nothing maybe to write down, but maybe just to talk about. Perpendicular bisector and median. These are the two big things here that take a little bit to solve and requires just a little bit of knowledge of really what they are. So I really kind of want to reinforce what these things are before we get rolling. So if we have like a line segment, yeah, we'll call it, or even maybe a triangle actually. We'll call it X, Y, Z. Yeah? Good. Let's just say we wanted the perpendicular bisector. So perpendicular bisector of line segment XY. Yeah? I know it's a triangle. I know, see it. But we just want the perpendicular bisector of a line that goes through XY. So first, think about it. XY is just line segment right here. Agreed? That's really all we got to look at right now because they're only talking about line segment XY. And what do we know about the perpendicular bisector? What point do we need on line segment XY? What is the one coordinate we're going to go after here? The midpoint, absolutely. So right here, we want the midpoint of XY. Now, our line, what's the relationship? Because we have the point, which is great. Now we're looking at slope. What is the relationship between our perpendicular bisector slope and the slope of XY? That's it. They're negative reciprocal. So whatever the slope of XY is, our slope of the perpendicular bisector, which is going to look something like that, has got to be the negative reciprocal. Because folks, once you have the point and the slope, you can get the equation of the line. You agree? No problem. Once we have the point and the slope, it's actually, that's the easier one of the two. Any questions about perpendicular bisector? Okay. Median. Median, let's say it also comes from this triangle x, y, z. How about we talk about the median from, and we'll say something like this, from x to y, z. So from x to y, z. We know this is the vertex, starting there. And where are we going? We're going towards where? Yeah. Yeah, that's it right there. The midpoint of YZ. It's this line that goes like that. So if we're able to calculate the midpoint of YZ, we have X coordinate, YZ, the midpoint of YZ, a coordinate. Now we have two coordinates, and we can just calculate the equation of the line. And that's, folks, if you're sitting there and you're like, yeah, I know, that is great, because this is going to be great. But if you're sitting there thinking, oh, maybe you can kind of see it, we're going to do an example, and hopefully by the end of it, you're on board. And if not, you let me know. So before we get rolling, we have here, determine the equation of a line in the form y equals mx plus b. That's parallel to y equals 3x plus 4 and passes through negative 3, 8. So when a line's parallel to one another, what do we know about their slopes? They're the exact same. They're equal. So our line is parallel to this line here. So that means our line must have the same slope. Yeah? And also our line, it passes through negative 3, 8. So that x value here is negative 3, and the y value here is 8. And off we go. We can kind of just go ahead and plug this into y equals mx plus b. And we're going to be able to solve for b as we did similar to the other day. So it'll be something like 8 equals 3 times negative 3 plus b, negative 9 plus b. Wow, I was thinking 6. I don't know why. The morning brain. 8 plus 9 equals b, and we should have something like 17 equals b. So you can see how when we have the point and the slope, it's not bad at all to get the equation of a line. So we can say, therefore, the equation is y equals 3x plus 17. Okay. Now this one's here is a little bit tricky because it's talking about a line that's perpendicular to this nasty thing here, but has the same y-intercept as y equals negative 4x plus 12. So again, when you're thinking perpendicular, I know that you're thinking negative reciprocal. But unfortunately, this line here is not given to us in y equals mx plus b. So it's not like the slope is just negative 5 because we have a 10y out front. So maybe we can take this equation and put it into y equals mx plus b by dividing everything by 10. We have something like y equals negative 5 over 10 is like negative 1 over 2x plus 1 over 5, I suppose. So our line is perpendicular to this line. So if this line has a slope of negative 1 over 2, our line, which is perpendicular, must have a slope of what? Yeah, 2 over 1. So I'm gonna write it like that. Our line is perpendicular, yeah? Perpendicular, it's almost like a little 90-degree upside down T with a little 90-degree thing there. Our perpendicular slope is 2 over 1, or just 2. This is what we like. Now, the next hint they kind of give us here is that we have the same y-intercept. And this is in y equals mx plus b. So 12 is for sure the y-intercept. We didn't have to really do any work for that one. So now, our equation must be y equals 2x plus 12. Perpendicular slope, got it. Same y-intercept, got it. That's kind of like a flashback to grade 9. You remember those types of questions? And sometimes they are taught, or maybe I threw those ones at you where it's like, the vertical line going through this point, and you really had to think about it. You're like, oh, it's like a giant point. It was like 40 negative 100. You're like, oh man. Okay. Folks, here we are. I hope that graph turned out okay on your end, and it's a little tiny. There's tons of space down for you to write. So if you're the type of person who wants to put these little headers, absolutely. But we have the steps up there, which is usually pretty good. But there's tons of space for you to write there. So don't be scared to use it all up. So if you're a steps person, this is for you. But there's some people in here that might want, like I had students in the past that they just memorized the steps. And I know there's not much learning going on, but sometimes that's just what it takes. Others, and I feel like based on what we were talking about earlier with the perpendicular bisector and median, I feel like you guys have a really good understanding of this already. You're like, yeah, okay, this, okay, sure. And it should be good. So, steps for determining the equation of the perpendicular bisector. So, those are up there. Here's what the question would kind of look like. Find the equation of the perpendicular bisector of the line segment joining C, negative 5, negative 2. So here, negative 5, negative 2. Good. And D, 3, negative 6. Got it. So here it is. There's the line segment. Now what we're after here, again, is the perpendicular bisector. So, the first step, actually, this is a funny one because it doesn't really actually matter where you start, but just for some consistency, the first thing we're going to do here is calculate the slope of this line segment. Does anyone have any idea as to why we might be calculating the slope of this line segment? Why are we getting the slope of this one? Yes. Tiana said that to find the slope of our line, which is perpendicular to this one, we could just find the slope of this line segment CD and do the negative reciprocal to get our slope, which is perfect. So I think the first thing I'm going to do here is say, okay, number one, let's do the slope of CD. Nice little title there. Step number one, just so we can correlate this. So M equals y2 minus y1 over x2 minus x1. Great. M equals, let's do negative 6 minus negative 2 over 3 minus negative 5. Go right to a calculator. Maybe negative 4 over 8. which is negative 1 over 2. Did I mess that up anywhere? Looks good? Okay. So we have the slope of our line segment. It's negative 1/2. Step number 2, it says calculate the slope of the perpendicular bisector, which is our line, by determining the negative reciprocal, the flip and change the sign, the flip and switch. The negative reciprocal slope of this thing. So, step number 2, we're going to write perpendicular slope. So if this current slope is negative 1 over 2, our perpendicular slope is positive 2 over 1, which is really just 2. And to kind of reiterate that perpendicular slope, I do put this little subscript that identifies a perpendicular something is going on here. And you might not do that, but I highly suggest to do it, and you'll see why maybe near the end. Okay, so we have the slope of this line. We know what it is. So here, it's perpendicular at this point. This is what we see. It's perpendicular. We don't know. What do you think the next thing is? We have this slope. What do you think, Ryder? Yeah, we need the midpoint. That's the next. Determine the midpoint of the line segment. So let me go down here. This is step number 3. We are going to say midpoint. Midpoint of CD. So you'll always have the formulas no matter what, but just to look at our toolkit here, the midpoint of CD, yeah, see the little subscript here, equals, and this is a coordinate, x1 plus x2 divided by 2, y1 plus y2 divided by 2. The midpoint of CD is negative 5 plus 3 over 2, comma, negative 2 plus negative 6 over 2. Close the bracket because this is a coordinate. The midpoint of CD, oh, I was almost thinking negative 8. I almost walked into the trap. But this is going to be negative 2 over 2, comma, negative 8 over 2. The midpoint of CD is now negative 1, negative 4. Good? I think it's good. Negative 2, good. And the best part about this sort of stuff is that because we have it on a graph, we can go and kind of just plot this thing. And if we're way off, something might have went wrong. So let's go ahead and do negative 1, negative 4. Does that look like the midpoint? If we take a step back and have a look, yeah, that's pretty fair. Pretty fair call there. So this is the midpoint of CD, and its coordinate negative 1, negative 4. Now, this is it. That was step number 3. Step number 4 is determine the equation by plugging in the slope that we got. And not any slope, because we have a couple of slopes here, right? We want the perpendicular slope because our line is the perpendicular bisector. So we want the perpendicular slope and also a point on our line, which there's only one that we know, and it's the midpoint. So step number 4, we'll call it equation of perpendicular bisector. And I use some short forms there. I'm going to grab the information that we know. We know that our perpendicular slope is positive 2. We know that our midpoint of CD is -1, -4. So we're going to take this information and plug it into y equals mx plus b. I wrote this little header here in case I wanted to take note of that. Just sub mx and y into y equals mx plus b. So y equals mx plus b. This will be our x, this will be our y as always. So we get something like -4 equals 2 times -1 plus b. And here we go, we're almost done. -4 equals -2 plus b. -4 plus 2 equals b. And -2 equals b. Therefore, here we are, the grand finale. Therefore, the equation of the perpendicular bisector is y equals 2x minus 2. Not so bad, or what? Not bad? Okay, it's all right. It does make sense. Like, if you're able to take the word perpendicular and bisector, and you have a really good knowledge of getting the equation of a line, it's not so bad. So when we go here, what is that? 2x minus 2. So sure, I'm gonna start at -2, rise 2, run 1, rise 2, run 1, rise 2, run 1, rise 2, and here we go. This is our perpendicular bisector. And if you have a look, it looks quite perpendicular. And we know that it is for sure because the slopes are negative reciprocals of one another. So that blue line there is the perpendicular bisector. Folks, any questions? You all right with that? That's great. That's awesome. Okay. Next one here. Oh, that was my blank page, so you guys had a ton of space. Okay. The next one here is the median. I know we just spent a ton of time on perpendicular and bisector, but median. Median is a line that goes from a vertex on a shape, and it goes to the opposite side's midpoint. That's what we call a median in a triangle. Oh. Yes, of course. You too. Folks, the median. Let's go ahead and read this thing and see what it looks like. It says, given a triangle with vertices A, B, and C, here they are, determine the equation of the median, and they're very specific here. They say from A to BC. That is very important. You know, it's not going from anywhere. You know, perpendicular bisector, it's from one line segment. So it's kind of like, all right, midpoint, slope, perpendicular, off you go. But a median, there could be a total of 3 medians in one triangle. In fact, they all meet at a certain point. Okay? Oh, that's just really going into some nerdy stuff there. So let's go ahead and plot A, -7, -2. Here we are. That's coordinate A. -7, -2. B is -3, +6. -3, +6. And C is 7, -4. Okay, I'm going to pull out a ruler. Well, I get to kind of cheat here. Oh, it's blue. Oh, that's so off. Here. Yeah, I knew that was strange. Good. Amazing. Okay, I'll give you a moment to grab that. Connect the dots best you can. Alrighty. So, folks, our median. They're quite specific, as I mentioned before, and we highlighted this. It's the median from A to BC, not British Columbia, A to BC. So from this coordinate A, we are going towards the opposite side length. But where do we actually go and cross the opposite side length BC? What? The midpoint. Yeah. So let's just pretend it's there. Boom. This is the line that we're getting at. So we have coordinate A. We have it. It's -7, -2. So all we really need here is the midpoint of BC, which it kind of looks like it is there, right? It might actually be there. And once we have those two coordinates, folks, off we go. Slope, y-intercept, state the equation, done. Bingo bango. So, but if you're a steps person, here we go. Step 1, calculate the midpoint of the line segment. Now that kind of sounds weird and a little misleading, but if you look at what we highlighted here from A to BC, A is a vertex. That's not a line segment, that's just one point. BC, this one here, yes, this is the line segment because there's a start and a finish. Okay, so step number 1, midpoint of BC. Midpoint of BC is x1 plus x2 divided by 2, y1 plus y2 divided by 2. B and C. So -3 plus 7 over 2 and 6 plus -4 divided by 2. Is that right? B, C. Okay, something's off here, no? -3 and I think I said 7, but I wrote 4. Yeah? -3 and 7. 6 plus -4. Okay. And it's good that we go back and verify that, because who knows, we carry this whole thing out. Oh man. Oh man, oh man. M of BC. Pause. No more risks. No more. -3 plus 7. 4 over 2. Lovely. 2 over 2. Okay. The midpoint of BC is 2, 1. And what's beautiful is that if for some chance we may have messed this thing up, when we were to plot the midpoint, you would kind of understand something's off. So when we plot 2, 1, like that's right on the money, right? Like that's undoubtedly on the money. So we'll say this is the midpoint of BC, and it's 2, 1. So because our median is quite literally this line here, we'll do it in red. This is the line. Good, like that. This is our median. We need the equation of that line. At this point, you can almost put the steps away and you just kind of know. But if you are the steps person, we're going to calculate the slope using the vertex. Now, vertex meaning like the vertice here, which is in our case is coordinate A, and also the midpoint of BC. And it says here, this is the slope of the median. And I don't think we're shocked by that. Okay, I'm going to work down here, I think. Step number 2. We're going to go for slope of median. So we have two coordinates. We have A, which is our vertex, -7, -2. And we also have the midpoint of the line segment, which is BC. That was 2, 1. Yes, just to confirm? Okay, good. So here we go. M equals y2 minus y1 over x2 minus x1. Really slow here. xy, xy, 1, 1, 2, 2. We have 1 minus -2 over 2 minus -7. 3 over 9? Is that right? 3 over 9? Okay. Which reduces to 1 over 3. And reducing means the top and the bottom, like the numerator and denominator, are both divisible by a common multiple. So they're both divisible by 3, so we can reduce that fraction. And this right here is the slope of the median. It's 1/3. That is our slope. And then step number 3 here, folks, is the equation of the median. So we have the slope, which is 1 over 3. And now we need at least 1 point on the line. Just to be consistent, I'm always going to choose the midpoint. Always. I will always choose the midpoint here. And the reason for that is because when you get to this point, when you get to this part, when you're determining the equation, for both the perpendicular bisector and the median, you could just sub in the midpoint with the slope. Okay? But realistically, hey, yeah, we could use point A if we wanted to, or the midpoint. I'm just going to use the midpoint every time. But you're not wrong to use coordinate A. And we'll say here, 2, 1. Here we go. Y equals mx plus b. You can say 1 equals 1/3 x plus b. If you remember multiplying fractions, the 2 is really 2 over 1. And when you multiply fractions, top to top, bottom to bottom, remember that? Or, I mean, hey, plug it right in the calculator. It's what we have before. 2 over 3 plus b. So we're going to bring this 2/3 over. So we have 1 minus 2/3 equals b. And if you think about it, you have one whole, and you take away 2/3 from it, you're only left with 1/3. Okay? Now, if you decided to change the decimals here, I would not be upset. I'd be a little disappointed, but I wouldn't be upset. So, down here, Therefore, the equation of the median is, check this one out, y equals 1/3 x, because that's the slope, 1/3 x, and this is plus 1/3. Kind of nasty numbers, but kind of manageable. Questions about median? Okay. All right. That's all I got. Now, I threw on 18 here. Did I throw on 18? Can I please see a textbook? No, I didn't put it on there. Yeah, I know. Let me see this in some greater detail. Folks, 18 is nice and everything. I don't think that's what we're after right now. So how about we scratch out 18, and what I am going to put on, though, is page 95, number 5. And this page 95, number 5, isn't yet on the little homework thingy at the front. But it is on the board here. You can see it not only on the active board, but also on the whiteboard right here. Yeah? It looks like there's only about 4 questions here. But yeah, I know, there's probably A, B, C, D, sure. Okay? I highly recommend using some graph paper, draw these things, see what they look like. If you need sticky notes, please let me know. I got tons, and I'm not afraid to order more, or maybe we could even march down to Mr. Todd's room and get a bunch more for ourselves. These are the ones we have. We used to remember the little yellow ones. Who remembers those little yellow ones? Remember those? Weren't they great? We ran out. I don't know what happened. But we do have these, which are, I think, just as good. So if you want one of these, and when I say want one, I don't mean peel one off and go and sit down. I mean, like, take the whole package. Like, take it with you, take it home, totally your call. There's graph paper is a great idea as well. I noticed that a lot of us have those graph paper, 200 pages of graph paper bundle. Yeah, it's all good though. If you need anything, ruler, calculator, you let me know. Time reactor. Oh, we have good time. Great time.